Maximum power transfer theorem. In this video, we are going to verify maximum power transfer theorem using TINKERCAD. This is the circuit diagram for maximum power transfer theorem. In the circuit diagram, we have 9-volt power source, Thevenin's resistance, load resistance which is variable, and to measure voltage we have voltmeter, and to measure current we have ammeter. This is the table that we are going to use for maximum power transfer theorem, and the Thevenin's resistance or source resistance is assumed to be 100. So all the 6 readings will be 100, and the load resistance we are going to vary from 50 volt to 200 volt. So slightly we are going to vary, and as we know that the maximum power will be transferred when the source resistance is equal to load resistance. The serial number 3, 100. At this time we should get the maximum power, and we are going to measure the voltage, we are going to measure the current, and we are going to fill in the table, and then we are going to calculate the power. So as per our maximum power transfer theorem, when the source resistance is 100 and the load resistance is 100, we should get the maximum power. Okay, now let's verify using TinkerCAD. For 9-volt source, let me choose the battery. 9-volt battery is chosen. Then for connecting the resistors, let me choose breadboard. Breadboard. So from 9-volt, we are going to connect the resistor, that is R Thevenin, which is 100 ohm. So resistor which is 100 ohm. 100 ohm resistor, this is R Thevenin. And next we are going to connect an ammeter. So for that I am going to choose multimeter. Should be connected in series with the resistance R Thevenin. Ampere. The negative terminal of the ammeter should be connected to load resistor RL. So another resistor, and this is RL load resistor, which is going to be variable, and then we are going to close the circuit. So this RL is connected to negative of the battery, and the positive of the battery is connected to R Thevenin, and then we have to connect voltmeter to measure the voltage across the load resistor. So another multimeter. This meter is going to measure the voltage across this load resistor. Therefore, positive is connected to the upper terminal, negative is connected to the lower terminal of the load resistor. Now I am going to vary this resistor and I am going to note down the readings. So start simulation. This one, it should be 50 ohm. 50 ohm. Start simulation. So I get current is 59.4 milliamps, voltage is 2.97. This one we have to record it in the table. Current is 59.4 milliamps. current is 59.4 milliamps, voltage is 2.97 volt, 2.97 voltage. Right, next I am going to vary this to 80 volt, 80 ohm resistor. Current is 49.6 milliamps, 49.6 milliamps. Voltage is 3.97 volt. Next, I am going to change it to 100 ohm resistor. 100. Voltage is 4.47 volt. 4.47 volt. Current is 44.7 milliamps. 44.7 milliamps. Next, I am going to change it to 120. So when I change 120, current is 40.6 milliamps. 40.6 milliamps. Voltage is 4.88 volt. 4.88 volt. Next, let me change it to 150. 150 ohm resistor. At that time, voltage is 5.37 volt. 5.37 volt. Current is 35.8 milliamps. 35.8 milliamps. And finally, the ohm is 200 ohm resistor. Now the current is 29.9. Voltage is 5.97. 5.97. Now let's calculate the power. So calculating the power, 2.97 multiplied by 59.4 milliamps gives 0.176 watts. Next one, 3.97 multiplied by 49.6 milliamps gives 0.196 watts. Next, 4.47 multiplied by 44.7 milliamps gives 0.199, which is almost 2. Next, 4.88 multiplied by 40.6 milliamps gives 0.198. Next, 5.37 multiplied by 35.8 milliamps gives 0.192. Finally, 5.97 multiplied by 29.9 milliamps gives 0.178. So from this, we can conclude that when the source resistance is equal to load resistance, we get maximum power. All other powers are less than 0.199, that is 0.2. Hence, maximum power transfer theorem is verified.